So the next section we're going to talk about is parametric equations. So let's imagine that a particle moves along the curve C that I'm going to draw right here. So let's say the particle moves up this way and then goes this way and this way. So this is the curve C, and then there's a direction the particle is following. It's going in this direction here. So this curve, the one thing we want to notice is that we can't describe C by some kind of equation y equals f of x, because this curve C fails the vertical line test. This curve is not a function. So basically what we do instead, what we can do is we can write x as a function of t and y as a function of t. So think about t as being a variable corresponding to time. And so your position x depends on time and y depends on time. And these are called parametric equations. So now we want to sketch some parametric equations. So let's look at the following example. I want us to sketch and identify the curve defined by the equations x equals t squared minus 2t and y equals t plus 1. So again, go back, think about plotting points. We're going to choose a value of t, and that will determine my x and y coordinate for a point. So let's pick some varying values of t. Let's go -2, -1, 0, 1, 2, 3, and 4. And so you plug these values of t into these two equations right here to get the following point. So if I plug in -2, x will be 8, y will be -1. If I plug in -1, you'll get 3 for x, 0 for y. 0, you'll get 0 for x and 1 for y. 1, -1, 2. If you plug in t equals 2, you'll get 0, 3. 3, you'll get 3, 4. And t equals 4, you'll get 8, 5. And so now when you go to plot these points, you're really only going to look at these last two columns. You don't need this first column anymore, and you're just going to plot these points here. So let's see, the first point is 8, -1, then 3, 0, 0, 1, -1, 2, 0, 3, 3, 4, and 8, 5. So now we can connect these points together to make the following picture. And there is a direction to these parametric curves, so you want to draw arrows indicating the direction as t increased. My curve went that way. All right, and so what is this graph? We've sketched the graph. We want to identify it now. What does this graph look like? This graph looks like a parabola. So I'll say this graph, if I had to guess, looks like a parabola. But let's verify this. We can eliminate the parameter t. So go back to, let's go to our y equation. Y was t plus 1. So I'm going to take this and I'm going to solve for t. T will be y minus 1. And then you're going to go to your x equation. Our x equation was x equals t squared minus 2t. And you're going to take this equation we have and plug in for t. So now you're going to get x equals y minus 1 squared minus 2y minus 1. And if you multiply all this out, minus 2y plus 1 minus 2y plus 2, you'll get x equals y squared minus 4y plus 3. And this right here, this is the equation of a parabola. Now I do want to mention that sometimes we restrict t to a finite interval. So for this last problem, let's stick with the same equation. But now let's say t goes between 0 and 4. So here's my finite interval right here. And so how is this going to affect my picture? Well, you're only going to plot points between when t is between 0 and 4. So if you go back to your table and you look at your points, I had, when it was 0, I had 0, 1, negative 1, it was 2, 1, it was there, and then the last one was at 8, it was 5. So I had this kind of picture. So I have a starting point and an ending point for my curve. So in general, if you have your parametric equations and you have a finite interval, if you plug in the start of that interval, a, into your function, we're going to call this point the initial point. So that was this point that right here that we started with. And then if you plug in the end of your interval, we would call that the terminal point.